Have you ever felt like your data is living in two completely different worlds? Well, today, we're going to tackle that exact problem. We're diving deep into Databricks, a platform that's all about unifying your data, analytics, and AI. We'll look at how you can get onto the platform, and maybe even more importantly, how you can master your costs once you're there.
For the longest time, so many organizations have been living with this split personality in their data architecture, right? On one side, you've got the wild, creative world of data engineering and AI, and on the other, you've got the superstructured, predictable world of business intelligence. And the result? Well, it's complexity, it's duplicated work, and it's these frustrating data silos that just slow everybody down. And this visual just captures that classic divide perfectly. On the left, you've got the data lake. Think of it like a giant natural lake. You can throw anything and everything in there. It's perfect for all that raw, messy data that fuels machine learning. But yeah, finding exactly what you need can be a bit of a treasure hunt. Then on the right, you've got the data warehouse. It's like a perfectly organized library, highly structured, super reliable, and really fast for BI. But it kind of chokes on all the messy data types that modern AI needs.
So the big question is, right, how do you get the best of both worlds? How do you combine that awesome flexibility of the lake with the rock-solid reliability of the warehouse, but without the massive headache of managing two totally separate systems? This is the exact problem Databricks was built to solve with its unified Lakehouse architecture. And here it is, the Lakehouse. The idea is so simple, but it's incredibly powerful. By building on open-source tech like Apache Spark, it creates a single platform, one single source of truth for all your data. And what that means is your data engineers, your data scientists, your business analysts, they're not working in separate worlds anymore. They're all working together on the same data, which finally breaks that endless cycle of moving and copying information all over the place.
Okay, so let's get practical. How do you actually get your existing data and applications onto this platform? If you're coming from an older system, what does that move really look like?
Migrating from a system like Hadoop isn't just about, moving boxes from one warehouse to another. It's a strategic upgrade. Think of it like this. You're moving from an old train that runs on fixed tracks, which is great for heavy, scheduled loads, to a whole fleet of high-speed jets. You have to repackage your cargo and completely rethink your routes to really take advantage of the insane speed and flexibility of Databricks and its Spark engine.
Now, when you break down the migration like this, it feels way less scary, right? You start by planning. You use tools that track your data's entire journey, what we call column-level lineage, to figure out what's absolutely mission-critical. Next, you do a lift and shift to get the raw data into the cloud. But the most important part is step 3, adapting and optimizing your code. For instance, translating older HiveQL to the much faster Spark SQL. And then finally, you validate everything to make sure it not only works, but it actually works better than it did before.
All right, so you've done it. Your data and your workloads are on the Lakehouse. Now comes the big question for any cloud platform, the one that keeps CFOs up at night. How do you manage the costs? How do you use all this incredible power without completely blowing your budget?
Okay, this slide right here reveals the single most critical insight for managing Databricks costs. Look, while you pay for stuff like storage, the vast majority of your bill, we're talking 60 to 80%, comes from one thing: compute. And that's measured in what they call Databricks units, or DBUs. This tells you exactly where to focus. If you want to get a handle on your spending, you have to get smart about how you manage compute, period.
And it's a classic saying for a reason. You literally can't optimize costs that are invisible. So step 1 always is to get clarity. And that starts with a really consistent tagging strategy so you can see which teams or which projects are spending what. From there, you can use the built-in dashboards and system tables to get a super granular line-by-line view of exactly where every single dollar is going.
This is probably one of the most common and most expensive mistakes we see teams make. Think of it like renting a car. An all-purpose cluster is like renting a car by the day. It's perfect when you're exploring and you don't have a set schedule, but it's pricey. A job cluster is like taking a taxi directly to your destination. You pay for that specific trip, and that's it. So for your automated pipelines, always use job clusters. They cost way less, and they shut down automatically, which stops that idle meter from running up your bill.
The great news is Databricks gives you this powerful toolkit of automated financial guardrails. Auto-scaling is like an accordion. It expands and shrinks your compute power to perfectly match your workload, so you never overpay. Auto-termination is that simple but brilliant kill switch for idle clusters. Spot instances let you tap into discounted spare cloud capacity for huge savings on certain jobs. And finally, cluster policies let your admins enforce all of these best practices, making cost control the default setting for everyone.
And you can never, ever forget this simple equation. Faster performance equals lower costs. Less time spent running a query means less money spent on compute. It's a direct relationship. And that's where Photon, Databricks' native query engine, comes in. It basically supercharges a lot of your workloads, making them 2 to 3 times faster. And that performance boost? That translates directly into DBU savings on your bill.
So what's the real-world impact of doing all this? Of choosing the right clusters, automating your controls, and boosting performance? Well, when organizations actually put a structured plan in place for this stuff, they have consistently seen cost reductions of up to a staggering 45% compared to just letting things run wild.
So let's bring this all home. What are the key takeaways for building a data platform that is both unbelievably powerful and actually financially sustainable?
You know, it really just boils down to a few key principles. First, unify your data with the Lakehouse to finally break down those silos. Second, migrate strategically with a clear step-by-step plan. Third, and this is the big one for your budget, you have to relentlessly optimize compute because it's your biggest cost. And finally, you automate and you govern. Use those built-in tools and policies to make sure those savings actually stick around for the long haul.
And when you follow these principles, when you really get this stuff right, you're left with the most exciting question of all. Once your data is unified and reliable and your costs are totally under control, you free up your teams and your budget from just fighting fires and managing complexity. You free them up to focus on what actually matters, driving innovation. So the real question isn't just about saving money. It's, what will you build next?